Hello, dear students. I hope you all are doing well. So, I'm going to explain autoprotolysis of water, which is a very important topic. I think the class 12th students and those who are preparing for JEE and NEET have already studied this topic, and class 11th also till now they have. I think you all guys have studied this topic. So, like I'm going to explain autoprotolysis of water and why this topic is very important. This is also known as self-ionization of water. So we all know we have water. It can self-ionization means, or autoprotolysis means, it can convert into its ion. So it will convert into H plus ion and OH minus ion. So this is the reaction, but this is not the correct way to write. If you are writing in the correct way, it will be written like this. But to understand the pH, because pH equal to negative log of H plus ions, so I'm writing as H plus. So let's start with this. So here you can see I have water which has been prototyped as H plus and OH minus ions. It means if I'm going to write K4, or a dissociation constant of water, means Kd. So it will be equals to concentration of H plus ion into concentration of OH minus ions divided by concentration of H2. This Kd is known as dissociation constant of water. Dissociation constant of water. So when water is autoprotolyzing, the concentration of water, the concentration of water is constant. It means it does not affect the equilibrium constant, or it does not affect the dissociation constant. If it is a constant value, and we know that Kd is also a constant, simply we can multiply it with the Kd. So what, to understand how it is constant, so let I have 1 liter of water. In 1 liter of water, I want to know number of moles of water. So how many moles are present in 1 liter of water? It's very simple. Density of water is 1 gram per liter, or 1 gram per ml, or 1 gram per centimeter cube. It means for 1 liter, mass will be 1000 gram. So if mass will be 1000 gram, simply what I can do, if mass will be 1000 gram, simply what I can do, yeah, then simply number of moles will be mass divided by molar mass. So it will be 1000 divided by 18. So I have, after calculating this, the number of moles will be 55.55, and concentration is equals to number of moles divided by volume, and volume is 1 liter. So simply I will get the concentration as 55.55, which is a constant value. It means it means it means again I will come back to this. I can multiply Kd by the concentration of H2O will be equals to concentration of H plus ions into concentration of OH minus ions. This new constant is known as Kw, which is known as ionic product of water. So this is very important. So this Kw is equals to into Kd into concentration of H2O will be equal to concentration of H plus into concentration of OH minus ions. So from here, what I will get? So from here, there's an interesting thing comes, that concentration of H plus ions will be equals to concentration of OH minus ions will be equal to 10 raised to power minus 7 mole per liter. This will be for pure water. So for pure water, I have concentration as 10 raised to power minus 7 mole per liter. So from here, there is an interesting thing comes. Look, I have already told you guys that if I am writing P of something, it will be always equals to negative log of something. Suppose I want to know pKw, so it will be negative log of Kw. So from here, I am going to calculate at 25 degrees Celsius the value of pKw. It will be equals to 14. So at 25 degrees Celsius, the value of Kw will be equals to 10 raised to power minus 14, because Kw equal to negative log, Pkw equals to negative log of Kw. It's very simple to calculate. Okay. So from here at 25 degrees Celsius, if I talk about the pH scale, so it will look like this. I have initial value 0, final value as 14, and between there will be pKw divided by 2, and this will be pKw. So pKw divided by 2 will be equal to 7. So this is known as neutral pH or neutral point. So at 25 degrees Celsius, the pH scale looks like this. And I have already told you guys in chemical kinetics that if I am changing the temperature, the value of K changes. That's why the pH scale will also change. So this pH scale is at 25 degrees Celsius. So I hope now you understand the pH scale. Okay. So why this topic is important? Let me write a question. Question is, calculate pH of 10 raised to power minus 8 molar HCl solution. Okay. So to solve this question, first of all, look at the concentration given. 10 raised to power minus 8 means 1 divided by 10 raised to power 8. So it will be like 0.000008. It's like very dilute solution of HCl. So when I am preparing the solution, in solution, I have HCl, I have water also. So I have already taught you guys about the autoprotolysis of water. It means water is also converting into H plus ion plus OH minus ions. So this will be our pure water. And I have HCl also inside solution. So HCl is converting into H plus ions plus OH minus ion. So it means H plus I am getting from two things. One is H2O and another one is HCl. So it means point comes when I am going to take this H plus for calculation. So this is very less value, like this will come out to be very less. So I have to consider H plus ions from water also. So when I'm considering H plus ions from water, it means the concentration of H plus ions from water will be equal to 10 raised to power minus 7 molar. And the concentration of H plus ions given in the question is 10 raised to power minus 8 molar. So total H plus will be equals to 10 raised to power minus 7 plus 10 raised to power minus 8. So it will be equals to, after calculation, it will be equals to 1.1 into 10 raised to power minus 7 molar. So now I can calculate the pH. Simple. I have already told you pH equals to negative log of H plus. And the concentration of H plus ions, you know, and now you can easily calculate the pH of 10 raised to power minus 8 molar HCl solution. So this is very important question. Now I hope that you understand autoprotolysis of water and ionic product of water. See you in the next video.